Yeah, we are live now. So, yeah, welcome everybody to this webinar. This is the third webinar of the preliminary webinars of the Congress, of the fourth SRI Congress, that will take place at end of June next year, 2026, and we will have more than 16 webinars before June. So this is our third one with Werner Grandl and his lecture about Lagrangean factory and industrialization of the geolunar space. So, yeah, give you the floor, Maria, for your introduction, and then we can start with the...
Sure. Thank you, Adriano. Welcome, everyone. We're so happy to have you among us tonight for this interesting topic. Actually, to give like a small abstract about it. So the utilization of the natural resources of our moon and the near Earth asteroids for the benefit of mankind will need industrial plants in space. The favorite locations for an initial space factory are the Lagrange points of the Earth-Moon system. There are 5 Lagrangean points, which provide an equilibrium between the gravity forces of Earth and Moon, especially in the points L4 and L5. An object remains in a stable position because there is a triangle between the object, the Earth, and the Moon. Building the first space factory in, like, for example, in L5 will enable us to process material and produce goods in zero gravity. Unlike on Earth or on the Moon, solar power is available for 24 hours. The industrialization of cis-lunar space will start with the mining of our Moon. The Lagrange Space Factory, LSF, will start with the processing of lunar material and extract iron, aluminium, titanium, and other materials from lunar regolith. An additional source for material will be the recycling of orbital debris to clean up Earth orbit. In the long run, the LSF will also process asteroid material, including gold, platinum, and carbon. The goal is to produce building material like steel bars, aluminium panels, tubes, and bricks for future space habitat. Furthermore, oxygen and space-made rocket propellant can be produced. The design of LSF should be modular to keep the structure flexible and expandable. Based on public-private partnership, the modules can be rented by private companies for industrial production. Our speaker is Mr. Werner Grant. He's graduated at the Technical University of Vienna 1994 as architect and civil engineer. He published several papers on studies for space stations and space colonies, utilization of lunar and asteroid resource. He is also a member of the SRI Board of Directors and chair of the Space Renaissance Academy, Space Tech, and Industry Committee, and also he is a co-chair of the Space Renaissance Academy Space Habitat Committee. So this topic is really like he's specialized in this topic, and now I will give him the floor and we will listen to you, Werner.
Okay, thank you very much for having me. Thank you, Adriano, for inviting me, and thank you, Maria, for your introduction. So I will just show you once the slideshow. Can you see the slideshow already? I hope you can see the slideshow.
Yeah.
Yes, well, so I will today speak some words about a Lagrange factory and the geolunar space industrialization. The industrialization of the Earth-Moon system is the essential presupposition for a human settlement in space. I think there can be no settlement in space in the future without industrialization, without heavy industry in space, and without mining in space. So there are several steps necessary for this. The first step is to erect a lunar base and mining of the moon. In a second step, we have to build a space factory in a Lagrange point, in the Lagrange point L4 or maybe in L5. In the third step, we propose the mining of near Earth asteroids and creating a cis-lunar space economy to produce goods for space and for Earth. And finally, in the fourth step, we can make a Lagrange city with simulated gravity for humans. The Earth-Moon system and its 5 Lagrange points, as Maria already has said, are providing an equilibrium of the gravity forces of Earth and Moon. And we look especially at the Lagrangean points L4 and L5, because there a space factory would be in a stable position. What you see here in this picture is, if you have a mass driver on the Moon, you can transport lunar material and of course also transport orbital debris from the Earth to L5. So the lunar electromagnetic mass driver was designed by Gerald K. O'Neill in 1976. It catapults containers with regolith into lunar orbit, and then from lunar orbit, space tugs are transporting the containers to L5. So this, you see here, this electromagnetic mass driver. It's a very old picture from the 1970s. Now, from the lunar orbit, there are unmanned robotic space tugs for cis-lunar transport. You see here the space tugs with cargo containers, and they can also catch orbital debris. The most important minerals in the form of oxides on the Moon for heavy industry in space are, of course, aluminium oxide, iron oxide, and so on. And you can also extract hydrogen from a material of the Moon by so-called electrolysis. So you can get hydrogen and you can get oxygen from lunar material. Now, what will be the main task of a space factory? First of all, the processing of lunar and asteroid material, especially of near Earth asteroids. Then the collecting and processing of orbital debris. We have now about 8,000 metric tons in low Earth orbit. Then the extraction of iron, aluminium, and so on, and other materials from lunar and asteroid ore. Then the main goal is the production of material, for instance, steel bars, aluminium panels, steel tubes, etc., and of course, propellant. And then we can organize the transport of semi-finished products to construction sites in the Lagrange points, and of course also to Earth orbit. So these are the main tasks of a future space factory. Then the next point we have to consider is asteroid mining. It is a main challenge of the future in space. You see here some geochemical groups for meteorites and asteroids with typical elements occurring in mineral associations. And as you see here in the table, there are many, many materials which can be needed and used for extraterrestrial mining and industry. For example, iron, nickel, gold, silver, aluminium, and so on, and even rare earth elements. So how to, sorry, once again, how to use these resources for the benefit of mankind. The first step will be to send robots to near Earth asteroids and, for example, to potential hazardous asteroids. On the next slide. So approximately 18,000 near-Earth asteroids have been detected so far. There are three classes of them. The first class is the Amors. They are beyond Earth's orbit around the sun. The Athens, the so-called Athens, they are very near approaching to Earth. And the so-called Apollos, which are also very near approaching the Earth. You see here in the sketch there the tracks. So this is a sketch of the Lagrange Space Factory in L5. Now the structure starts with a rotating habitat for the crew. The crew should have approximately 48 persons. And then along the central construction axis of the non-rotating manufacturing modules, here are the manufacturing modules. And of course, you can extend the space factory and along these axes. Now two other sketches of the Lagrange Space Factory, a cross section where you can see how it is built, and of course a view once again. On the left side, it is the rotating habitat for the crew, and here is the industrial facility. And here you see the main axis. First step, a rotating habitat for the crew. I have chosen a rotation radius about 40 meters, which would provide a simulated gravity approximately 70% G by a rotation rate of 4 rounds per minute. You see here there are 8 living quarter modules for a crew of 48 persons. Here you see a cutaway drawing of a living quarter module. There are always one and a second living quarter module. You see here those 8 living quarter modules. Here you see a spacecraft, a manned spacecraft, which is approaching to the station. Living quarter module for 6 persons. There is an upper level. It's here and here shown in the plan. You have the living and working area, about 77 square meters. And in the lower level, it's here in the section and here in the floor plan, you have the rooms for the inhabitants. And as you see, each inhabitant has his or her room, her private room. Now, I have made some considerations about the hierarchy in the L5 Lagrange Space Factory. Of course, the human crew is always on the top of the hierarchy. The human crew gives orders to artificial intelligence and controls robot and manufacturing. And then you have the artificial intelligence as a tool for the humans, and you have the robots as a tool for the humans. And artificial intelligence and robots are controlling and managing the industrial processing and manufacturing in zero gravity or in microgravity in L5. And then the output is the material and can be transported to L4, Earth orbit, and so on. So if you want to establish a Lagrange Space Factory, you have to have some precursory steps which are necessary within the next years. First of all, you have to build a new orbital station in low Earth orbit, which is succeeding the present ISS, and we prefer with simulated gravity. Maybe within the next 10 years until the year 2035. And then, of course, a manned lunar base with the electromagnetic mass driver some years later. And then the Lagrange Space Factory first stage may start to process lunar material and space debris from Earth orbit. Then, if possible, we start with the mining of the NEAs, of the Near Earth Asteroids, maybe in the year 2060 or so. And the second stage is then the processing of the asteroid material. And I think, and this is my opinion, my estimation, about the year 2050, we can start with the construction of large rotating habitats in cis-lunar space. And I want to show you now some examples. These are historic examples for a so-called Earth-Moon Lagrange city. Example number one is a wheel-shaped design. It is from the movie Space Odyssey from 1968. There are rings, and of course, if you start with the first wheel-shaped structure, you can extend it along the axis by adding similar wheels along this main axis. This is one example. The second example from 1976 is Gerald K. O'Neill's Island 1. It is a spherical structure with 500 meters in diameter and with additional structures for agriculture here. You see here a section, and you see how the light is coming in and illuminates the, once again, sorry, and illuminates this structure, this sphere. Gerald O'Neill has proposed about 7,000 inhabitants, and he has estimated approximately 3 million tons. Example number 3 is a cylinder with central lighting from the year 1993. It was one of my first works, as you see below. So this is a cylinder about 2,300 meter length and 900 meter in diameter. And as you see here, the light is coming in and focused by a mirror plant, and then through a window it is beamed into the cylinder, and and there is a cone which is able to enlighten the entire cylinder. And here you see a cutaway drawing of this cylindrical. Now, of course, what is also important is human travel in cis-lunar space between Earth orbit, lunar orbit, and the Lagrangean points. So this is my last, my last design in this year. I have designed a space cruiser for this way of travel. The space cruiser simulates 0.5 g simulated gravity. I think this is enough for a journey of 3 to 4 days. It is not longer between all these things like the lunar orbit and the Lagrangean points. Length is about 100 meter, 76 meter in total diameter, and the crew is about 6 persons, and it is for about 18 passengers. So this is it was, and I thank you for your attention.
Thank you very much, Werner. Quite interesting lecture. And yeah, I think you are really putting together everything we will need to live and make industry in the geolunar space. And yeah, I've seen some new concepts like the space-to-space transport vehicle, something that well, maybe somebody is thinking about that, but it's not very much known. If there are some studies about that, they will be essential when we will really start working and living in space. So, okay, now let's see what happened in our audience if we have somebody watching. Jerry Stone. Okay, so I think Maria, maybe you could take the questions and comments from the audience and pass them along to our speaker. And I would like to remind all the people who are watching that they can make questions. They can pose questions to the speaker, and Werner will reply. And also, if you like to discuss something, you're very welcome. And first of all, you could post in the chat, who are you, where are you watching from? Let me also write something over there.
No comments.
Yeah. Maria, are you saying something?
There's maybe one question in the chats on YouTube from Jerry Stone. In the 1993 cylindrical habitat, how does sunlight reflect off the central cone backwards up in the cylinder without blocking the rays from further down the cone?
The central cone, is has so-called facets, and I should show this in detail. And the facets are made to distribute the light. It's a facet. It's a how shall I describe it? It's a mirror facets. You know what this is?
Okay, so I hope Jerry got his answer. If he wants to interact in the chat and tell us. Also, there's another question. On return to Earth, what amount of fuel is required to slow down into Leo? Surely all this has to be available at L4, L5, or in lunar orbit. So what amount of fuel?
Spaceships will be orbiting the Earth and also the Moon, and will transport the material down to Earth and to the Moon.
Okay.
Those spaceships I have not shown, of course.
Okay. Wonderful. From my side, this is everything in the chat. That's it. Yeah. Okay. I don't know, Adriano, if you want to say something more, ask something.
Yeah, I see that Jerry is mentioning Island Zero. Island Zero is the design made by Jerry, and he is proposing it to space agencies and to some possible investors to start working on that. And yeah, I believe maybe Jerry has a different idea about the timing possibility to realize the first rotating station with simulated gravity can be a little bit different from the roadmap you have sketched before, Werner.
Yes, I have proposed in the year 2035 to have the first rotating station in Earth orbit.
Yeah.
I don't know whether this will come faster or not.
Okay. I have Jerry who is asking again, but how do they slow down when returning to Earth? So I think he needs more clarification maybe on this point.
Returning to Earth is, in my opinion, possible by the new spaceship of Elon Musk. That's no problem.
How do they
And we can
slow?
also use a shuttle, like Jerry knows this project from I think England. I don't know what is the name of this project.
The Skylon.
Skylon
Sky.
project. Yes, it is a kind of a shuttle. Yes, of course.
Yes.
Of course, this can be used.
Great. Okay.
Yeah, I think the idea is that at that point in some years, some decades, we will have a system with orbital stations that will be, yeah, some kind of intermediate station that people can travel from Earth to the orbital station, and then from the orbital station, the Earth orbital station, to the Moon orbital station can travel by a space-to-space vehicle, and then take another shuttle to fly from to descend to the Moon surface, or to move
Yes.
to Lagrange habitats. So
yes, this is the idea. This is the idea. Yeah, this is the idea that you can travel from an orbital station around the Earth to an orbital station around the Moon, and uh, from these orbital stations you have to have other uh, rockets or what else to come down to Earth and lunar surface, for example.
And of course, the depots of fuel propellant will be on the orbital stations.
Yes.
There will be possibility to refuel over there.
Yeah.
To go for the interorbital travel, and for descending to the Earth or to the Moon.
This is also a concept which Musk is using or will use in some years.
Yes, so refueling in orbit. Yes, that
Yeah.
is. Of course, now we have to bring all our propellant from Earth, but when producing propellant from lunar or asteroid resources will be in place, we have availability of propellant in
Yes, then we have solved this problem. We have solved this problem then.
orbital depots. Yes, definitely. Yeah, it's a complex system that, of course, and somebody will call it an ecosystem.
Yeah.
to be constructed, to be built in the geolunar space, and we would like very much to see some coherent strategy to build parts of this system, and at the end to have the whole system working with the
I think
logistics.
that, yes, I think the entire strategy must be to land on the moon first and to
Of course.
build a lunar base, and then mine the moon, especially regolith of the moon, and then when you have the industrialized the Earth Moon system, you can do nearly everything.
Yeah, I remember Kraft Eric made a plan of 5 stages. The first stage was prospecting the moon to identify the most promising sites where to extract materials and so on. Then to the second stage was to start building on the moon, and so on, arriving to, well, Krafft-Ericke was thinking about a lunar city, of course, because he conceived what he called androcells in a more advanced stage. So Krafft-Ericke thought about Selenopolis, a city on the moon first, of course, well connected to the industrialization of the moon, and later androcells in free space. O'Neill, the vision of O'Neill was different. Gerald O'Neill was not thinking about a city on the moon. He was only thinking about industrial production on the moon, but living from the point of view of a human habitat were conceived by Gerald O'Neill in the Lagrange points and in orbit, in Earth and Moon orbit. So yeah,
of course we need also on the moon small habitats for the engineers and for the miners and for the scientists and so on.
In our Congress, we will discuss all of these things and try to understand what will be the balance between working on the moon and living in rotating habitats with simulated gravity. That will be very important for human health and biology in general. So reproduction and a lot of things that are quite important that we don't, that the human species doesn't need to face too quick changes in its physiology. So yeah, it's very important for us, simulated gravity and the O'Neill vision. And yeah, if we think about the current projects or visions, we think that the Jeff Bezos vision for cis-lunar logistic and and the plan for construction is more similar to the O'Neill vision. And in fact, Jeff Bezos, we know that Jeff Bezos is a passionate fan of Gerald O'Neill. So yeah, his plan is reflecting more this vision. So okay.
We have also on Mars the same problem, because Mars has only 38% of Earth gravity, and it would not be very convenient to humans to live on Mars for hundreds of years. It's the same problem like on the moon.
Yeah, exactly. And by the way, since studies are going on about creating electromagnetic artificial shields to protect from radiations, it would probably be easier to build such kind of electromagnetic artificial shield around a free space habitat than on a planet's surface, maybe. I don't know, but of course, some more detailed studies should be made, but it seems to me that to make a spherical protection shield, it could be easier than a dome on a planetary surface. Of course, planetary surface could offer a possibility to build underground habitats in order to be protected from radiations. But however, okay, these are all things that will be necessary, however, because if we have to work on Mars, of course, we will need to have quarters for the personnel. But important is to think about shifts, working shifts, maybe working one week on the surface and 3 weeks in rotating habitats. So it will be a very interesting working shift, okay? 1 week per month, for instance. But it can be also, it can be one week on the surface and 1 week on the habitat. Yeah, well, that will be duty of the managers that we have to understand.
We have to make experiments on this
Yes,
item, and I think here is Jerry right, because we have to make experience with artificial gravity.
definitely. And yes, another point that we will discuss at our Congress. Yeah, let me remind that this webinar of today and the others that we follow are preliminary to the Congress. So it is perfectly logical that we also talk about our Congress and what we will discuss. One very important point will be the rights of the workers, of the space workers, rights of the pioneers, the rights of the settlers. We in our recent activity at COPWAS in Vienna, we gave a speech called "We Speak for the Settlers." We speak for the rights of the settlers. To the settlers, we think that space resources belong, not to be intended in an old colonialist view, to go there, take the resources and bring them to Earth, but go there, mine the resources and build space infrastructure. So for the sake of the settlers, and more than okay, the Earth. The terrestrial people, we have other benefits, of course, because terrestrial people, terrestrial, I mean the one that will not migrate, that will remain on our planet, will of course benefit the civilian space development, because civilian space development will relaunch the economy, the global economy. So it will be a benefit for everybody on Earth and beyond. And it will be a great benefit for the emerging countries where the progress is just starting, industrial progress is just beginning. And so they will have a great benefit from space development, and will also be in our strategy. The access to civilian space development should be available in a fully inclusive mode for all people, all the people of Earth. So this is very important, and we are saying it loud at Vienna in COPOS assemblies and meetings, and we think that's very important, because there are about 100 countries, delegation of 100 and more countries that are listening, and surely they will consider these things in there. So I
think we are not knowing yet how a society in space will look like and how it will be organized. So there is a lot of work to do for our philosophy committee, I think, or the political committee.
Yes, definitely. So I am seeing in the chat that maybe Jerry is still writing something. Maria, are you following?
Yes, I'm here. So Jerry is correcting something about what he already said. I have said that sending a crew to Mars in and Island 0 means it could be slowed down during the journey, so they would be acclimatized to Mars gravity by the time they arrive. Okay.
Yes, this is possible, of course, because you can change the rotation rate of a spaceship, and when you are arriving at the Mars, at the Martian orbit, you can accommodate to Martian gravity. That's a good idea.
Yeah. Also, he commented about his previous idea about slowing down, and he said going to the moon or L4, L5 from Earth orbit is no problem, but coming back to Earth orbit needs fuel, unlike the Apollo re-entry, and this is what needs fuel, which must exist at the launch point. So yeah, so he was commenting
produce fuel. Yes, we can produce fuel in space, but we have at first industrializing of space. and mining of space.
Yeah, that's why I think that the first thing to do when we start mining the moon is producing fuel.
Yes.
Because this is really, we think that this is the second step after having a reusable vehicle from Earth to orbit. That is the first step to downsize the cost of everything. The second step is to start producing propellant in space from in situ resources, because
We
that
have
will mean another downsizing of the cost of any mission, because simply the fuel doesn't have to be brought up across the gravitational well. That is the big cost.
as I showed in my presentation, we have, of course, oxygen and hydrogen on the moon. So we must extract it from the lunar material. And then we get propellant.
Yes, great. So the earlier we start, the better. The better it is.
Yeah. I guess for the question, this is it on the chat. Actually, we're done for this part. If you want.
Great. So I just would also remind that to subscribe to our channel, YouTube channel is free, doesn't cost anything, but it is a great thing for us, for Space Renaissance, because the higher the number of subscribed people, the sooner we can start getting some money from advertising on YouTube. Therefore, it's very important to subscribe to the channel and also to watch our videos, because the number of watching hours is another parameter important. And you can find the wall calendar of the past webinars from 2021. So we have made almost 100 webinars from 2021. Many of them very, very interesting. So you can go there and see all of these webinars. The link is the links to these webinars are on the Space Renaissance Academy website. The URL is academy.spacerenaissance.space. Go there and see the calendar of the future webinars and of the past. And yeah, second thing, very important, we are an activist organization. So we live from the fees of our members. So it is very important, if you like what we do, to register as members of Space Renaissance International. I will just put the link in the chat now, so you can do it when you like. Just a moment, I will do it. At the same time, we still have some 10 or 15 minutes, if you like. We can have other questions to our speaker. He can reply, we can discuss. So we are not in a rush. We still have time to do it. Okay, I've just posted the link for the registration to SRI. And other very important thing, register to the Congress. I will also share the links now, and submit your abstract to the call for papers. So, okay, this is the link to the Congress website. Okay, then we have the link to the form to submit abstracts. How many links I am posting here today? And the link for registering to the Congress. It is also already possible to register to the Congress. The Congress, as you know, will be end of June next year, but you can register today. That will be important for us. It will be a support for Space Renaissance, an important sign that you are supporting SRI and you are participating to what we do. And our Congress, of course, is the most important thing for us for the next 5 years, because you know that we make a World Congress each 5 years, understanding the status of civilization in the perspective of extending into space. Okay. So very welcome everybody to join us in our Congress and in Space on board the Space Renaissance International. Now, if we don't have other things, we can also close this session.
Okay.
Werner.
So I guess that's all. I guess next time it's next Monday on the 20th, right? If I'm not mistaken.
Yes.
Yeah.
We
Okay.
will have Joe Pelton. Joe Pelton talking about protection from space radiation, from cosmic and sun radiations.
Great topic.
Very interesting lecture, because
Yeah.
it's talking about a very innovative scientific and technological possibilities to get protection.
Sure. Yeah.
Okay.
Werner, it was wonderful. Thank you so much for your lecture. It was so insightful and interesting.
Thank you, Maria. I thank you for your help and for your kind words at the beginning. And thank you, Adriano, for inviting me.
Thank you, Werner. Thank you, Maria.
My pleasure.
Bye-bye.